In section 114, we're still working on solving systems of linear equations. We're going to use matrices to assist us with this process. So that's our objective, is again to solve the system using matrices. To start, we have a situation where we're doing some Earth Day cleanup. For a week, a total of 2,150 pounds of trash was collected, 525 new trees were planted, and 9,750 pounds of electronic equipment was recycled. We had 3 different groups working. We had our middle schoolers, our high schoolers, and our college students. And as you can see, each group got a little bit more efficient at each of the cleanup types as they got older. So we're going to let X be the number of middle schoolers, Y be the number of high schoolers, and Z be the number of college students. So first of all, we need our 3x3 system. So if we look at the highway cleanup, middle school students were able to do 10 pounds per student. So total number of middle school pounds collected for all the students would be 10 times X. Plus, again, highway cleanup, the high schoolers did 20 pounds per student, so 20Y. And the college students did 30 pounds. And then this was going to total up to the number of pounds collected, which was 2,150. We can do the same thing for our trees planted. Each middle schooler planted 3 trees, each high school student planted 4, and each college student got 7. And that was a total of 525 trees. And last, 50 pounds of electronics for the middle schoolers, 75 for the high schoolers, and 150 for the college students, netting that 9,750 pounds of electronics recycled. So that is our system of 3 variables and 3 equations. Suppose we solve the system algebraically. Do the variables actually enter into calculations? Not really. The important things are the coefficients and how they're lining these up. So we're going to make a matrix of coefficients. It's going to have just the coefficient values, and then the variable parts are going to be represented by the columns in the matrices. Okay, so on to our next page. We actually want an the matrix of coefficients is like the part that just has the x, y, z. We actually want an augmented matrix because we also want to have our solution values in the matrix. Okay, so we'll get back to that tree cleanup or recycling cleanup in a moment. We also want to talk about getting a matrix into row reduced echelon form, or RREF for short. And the benefit of this is that this form has these ones along the diagonal of the matrix, and then some numbers, whatever C1, C2, they're all numbers right here along the last column. The advantage of it is this matrix can be read as 1x, or x, equals C1, because plus 0y plus 0z, then 1y equals C2, and 1z equals C3. So this matrix actually would be solved and would give us the solutions if I was able to take my original matrix and get it into row reduced echelon form. All right, continuing on to the next one. There's a big, long example of how to do these matrix operations by hand, which we can ignore because we're not going to do them by hand. We're going to use some technology to do this for us. Why would we want to rewrite our matrix in that row reduced echelon form? That's the solved form, right? Because the solutions are visible. That solves it. And that's how we're going to get our solutions. Okay. Next page. Again, there are some directions on how to do this stuff on a calculator. We're going to do it in Desmos, so we don't need any of those little bits. We're going to go ahead and solve this system from example 1 using matrices. So actually, no, they did that right here. So that's just an example. We're going to do it with the problem from number 1. Okay, so got to go back to my question, problem 1. What we need to do here is write our matrix for this system. All right, so I might be able to hold my page like this so I can see most of both parts. Okay, so I'll write my matrix over here to the side. In my matrix, I'm going to have a column for x's. So in my x column, I'm going to have my x coefficients. In my y column, I'll have my y coefficients and my z coefficients and my constants. So I'm just going to do the first row for the first equation. Don't write the variables, just write the coefficients. So 10, put a space, then 20, a space, then 30, a space, then the 2,150. Okay. Now that I know how much room it's going to take me to write this, I can write the closing bracket for my matrix. Same thing for the next row. For the next row, we have 3, 4, 7, and 525. And the last row, we have 50, 75, 150, and then 9,750. So in the matrix, we should see that each row is a new equation, and each column is for a variable, x, y, z, and then a solution value, a constant. Okay, so I need to solve this. So I need to get this matrix into row-reduced echelon form. Okay, so we're going to use Desmos to do this. Now, when I go to Desmos, usually the very first thing I do is pop into the graphing calculator. But now I'm not, because this is not a graphable type of question. If you look up here in Math Tools, there are other calculators. We don't use the scientific or four-function calculators very often because they're actually incorporated into the graphing calculator, and you can do order of operations, anything you can do in those two calculators right in the graphing calculator. If you didn't want the ability to graph, you could grab one of those, but I just find it's easier to use the graphing calculator. But you will see next that there is a matrix calculator. That's the one we're going to need right now, matrix calculator. Okay, so I'm going to enter a new matrix. And this matrix has 3 rows and 4 columns. So 3 rows and 4 columns. We're going to type in our values. I'm just going to hit tab to go between those spots right here. Tabbing again, entering my matrix. All right, so I've got all the values in my matrix. I just pressed enter. Now you can see down here, I have a bunch of these buttons are things that we would not use in this course, but RREF is the only one we need, that shorthand for row reduced echelon form. And then what matrix do you want to do this of? This matrix is called A, so matrix A. Ta-da! This is our row reduced echelon form of this matrix. So rewritten, this matrix is 1, 0, 0, 75, 0, 1, 0, 40, and 0, 0, 1, 20. All right, so that's solved. I just need to interpret the solutions of this. So remember that the first variable right here is x. So x is equal to 75. X plus 0y plus 0z. So I'm not writing down 0y's and 0z's. I'm just saying x is the only variable. I have one of them is 75. Then again, no x, just one y. So y is 40 and z is 20. And again, because this is a word problem, we're going to get rid of my decimal screen there. We're going to interpret this back in context. So X is the number of middle schoolers. So there were 75 middle schoolers. There were 40 high schoolers. And 20 college students. And that finishes this question. All right. If I was to have done this one by hand instead of with the matrix, it would have taken quite a bit more. I would have had to do elimination with these like two equations and maybe these two equations. Um, it looks like I could get rid of x with the top two if I make them both 30s. The bottom two, the top and bottom, if I make them both 50s, I would have to multiply to get rid of the x in the first two. I'd have to multiply the top one by 3, the bottom one by -10, add them up, and then 3 processes of eliminations as we did in section 113. Matrices are a lot more efficient, and the technology is able to assist us. So it's certainly going to be our preferred method, I believe. But there is a little bit of a learning curve for how to enter the matrix and how to interpret the results. All right, well, that's actually all for this section. I think I'll do one more example just for fun for the activities. So let's just make a note of a couple things. This one asks me to write the system of linear equations represented by this matrix. So x, y, number, the last one's always your number, so this one only has x and y. It doesn't have x, y, and z like this one here does. So this equation would be 4x plus 3y equals 15, and 2x minus 5y equals 1. That's the system. And then it does not ask me to get the solution in this context, but why not? Let's get the solution for this matrix. So we're going to get this into RREF form. And just one more practice here using the matrix calculator. All right, so I'm going to enter a new matrix. This one needs to have 2 rows and 3 columns. I'm going to enter our values for 3, 15, and 2, -5, 1. And now I want it to do RREF of B, since the name of this new matrix is B. And our solution here for this matrix is, I'm going to write this down, we have 1, 0, 3, 0, 1, 1 for the RREF row reduced echelon form of that matrix. And so that means that our solutions are 1x is 3, 1y is 1, or the ordered pair 3, 1.